I okay, so maps on the World Wide Web. So yeah, okay. So this week we're starting to look at web maps on the internet and the World Wide Web, and quite a reasonably short lecture today. Maybe just try and do it in a oneer and get done by about 1:15. Because there's some other, the practical takes a little while to do, or to find the stuff for. So I'm going to give you a short introduction, just sort of half an hour, I think, to what the internet is, what the World Wide Web is, and what we generally think of the Geoweb as. So it's going to be very broad brush stuff. And then I'll look at some detail and run you through primarily CRAC. I'm never quite sure whether it's crack or CRAC. It's web classification, classification of web maps, and also a more recent take on it that I think is personally thinks a bit of an improvement on that. And that's going to give us a tour of the types of maps that are on the web. And then in the practical, once we've finished, what I want you to do is to go away and try and find some examples of these web maps, or of the web maps that meet the various classes in CRAC's classification. Then we'll have a sort of show and tell, and we'll have a discussion as to whether we think they meet, how well they meet the various classes, and indeed how easy it is to find out whether they meet which classes that they're applicable to. So that's the idea. So first of all, well, just what is the internet? The internet and the World Wide Web are used in sort of common parlance to mean the same thing, but they are in fact different things, which I'm sure some of you are aware of. Basically, the internet is the physical structure, a physical network across which digital data passes. So it's a thing made up of computers, cables, routers, all these other magical bits of computer equipment that I really don't know much about, routers and cables and things that can handle computers. So it is this global physical network made up of hardware devices of various kinds. It includes printers, and of course increasingly with the, I don't know whether you've heard of the Internet of Things, we're adding more and more devices of various kinds onto the internet, including things like controlling the temperature in your house through your smartphone and things like this. Your thermometer in your house will have an IP address because that's how you can connect to it. So basically, it's how we connect, it's the things, the physical things that we attach to the computer network. These physical devices, hardware devices, are uniquely identified by what's called their IP address, their Internet Protocol address. And we'll see what an IP address is in things more in future lectures. I think that's probably next week. This week we're just looking at it at a high level. So they're uniquely identified by its IP address, and I'm sure most of you have heard of IP addresses before. That's not so good. What's going on? Oh, it's full disconnection. Right. Okay, so we've got hardware addresses. And these devices communicate with each other using something called the Internet Protocol Suite, Transfer Suite, TCP/IP, which you also may have heard of. I have never had to deal with TCP/IP directly, but it's the way, the way or the communication protocol that allows these various devices to talk to each other across the internet. So it specifies how the data is formatted, addressed, transmitted, routed, received. Basically, it's the address system, the postal system for the internet. This is getting a bit old now, but 2013, this is a map of the internet as it was in 2013. We'll see a few more of these in future lessons. Clearly, the internet is probably at least 2 orders of magnitude bigger now than it is, and this is probably, I think, in many ways one of the last attempts to, or seems to be one of the final attempts to see the internet in one picture. This was an attempt to see what the internet looked like as one picture. There are lots of other websites online that provide you overviews of the internet, but I think it's just simply so large now that it's almost impossible to create a diagram of the whole thing. So in this diagram, this is obviously not a geographic map. It's what we could call this is a network diagram. It's a bit of a hairball. I think I've used the term hairball before to describe these complex network visualizations, which kind of give you an overview and a sort of wow sensation of what you're looking at. But frankly, when it comes down to detail, one can question their usefulness. But what we can see here is that we've got these stars shapes. So basically the lines, each dot is an IP address. The lines indicate the delay in sending signals between those various internet addresses on the web. Longer lines, it takes further to communicate, so it's physically further, or usually physically further apart, but that's no guarantee on that. So we have the sort of overall structure of it. We've got these star shapes, which are presumably a node to which lots of other devices are connected. It wouldn't surprise me if some of these are things like Google and things like that, Yahoo, Facebook, things like that. If Facebook existed then, I can't remember whether it existed then. Also, it is coloured by the different extensions used in this case on the World Wide Web. So we have .NET, CA and US in blue, the COM and org in green, etc., etc. Okay, so so this is a sort of overview picture of the internet, and we can see in this detail, we can actually see these IP addresses associated, in this case, with one of these star structures or star-based networks. So that's a sort of, standing back and trying to look at the whole thing in one go. But if we consider it in more detail, the internet is in fact a hierarchy of networks. It is a network in itself, but it's a network made up of networks at different levels. So there is often a physical hierarchy to the infrastructure, not surprisingly, perhaps. So we have the infrastructure that exists, say, within our own homes, in our home networks, a personal area network, we might call that. Then we've got stuff maybe organised by organisations, local area networks. So, for example, Kingston University is basically a local area network. It's a whole variety of groups, and that may enclose areas that are personal, so to speak, within that sort of wider area network. And then as we go out to larger scale areas, people talk about things like near-me areas, metropolitan areas, networks, wide area networks, covering larger and larger geographical spaces. Not surprisingly, the internet in the UK, or the way the internet is implemented and designed, is one of the subweb networks that we could then embed within the global internet. So there is a sort of physical hierarchy that's generated as much by how the internet is put together and implemented and looked after. So who is putting in the equipment at the UK scale? Who is managing the equipment for the city of the internet cabling and stuff like that for the city of Newcastle under Lyme? Of course, there are often competing networks as well, dealing with the same geographical space. So there is this physical hierarchy and also overlay of sub-networks. We can also look at the internet through a hierarchy of access. So that was a physical hierarchy previously of the equipment and how it's connected. But we can also think of an access hierarchy, depending on who gets access to various parts of that internet. So clearly we have intranets, which are private closed off spaces that only people with certain permissions have access to. We have the internet, which is basically open, global, except obviously for these pockets of intranets within it, but that's part of it is open. And then we can have this kind of partial area where you can invite people in from the outside and things like this. This is from a business perspective, this diagram. So you can have basically bits of the extranet can be made, intranet can be made accessible to people outside. I think that's the way to look at it. So that's basically the internet. So what's the World Wide Web? Well, the World Wide Web came along quite a lot after the internet. The internet originally developed, and I'll talk about this in a later lecture, in probably the next lecture, in so early 60s, mid 60s, late 60s. It started with what's called ARPANET, which was an attempt to connect military installations and universities across North America, and ARPANET slowly built up into the internet. So the internet itself dates from, you could say, the early 60s, although it probably wasn't actually called the internet until I think probably the 80s, around that late 70s, early 80s. The World Wide Web doesn't come along until the early 80s, in fact 1989, and developed by Tim Berners-Lee when he worked at CERN, the European Particle Physics Laboratory. What is the World Wide Web? Well, the World Wide Web is a way of accessing information on the internet. So it's a set of programs and formats that you store, that run on the internet, that allow people to access different types of information. There are all sorts of other things running on the internet than the World Wide Web. The dark web, for example, and other things, although how well the darknet connects to the internet, but there's also things like file transfer protocols and other things going on the internet than just the World Wide Web. So the World Wide Web is basically about, or was originally about, providing information formatted as web pages, which we're all familiar with as documents, basically web-based documents, just like you would read a paper document, you're reading a document on the computer. And it's written, these documents are written in, or the content is written and formatted using what's called the hypertext markup language, HTML. And next week we'll be starting programming HTML. I'm sure some of you maybe have done some in the past. But the web now includes, so when it very first started, the web was HTML, and that was it. The web has now expanded, the World Wide Web. We now have a language called CSS, Cascading Style Sheets, which is used for styling web pages to separate design from content. We also have JavaScript programming language, which enables us to write interactive dynamic web pages. There are other programming languages that can be run within the web or embedded within the web, so you can get Java applet programs, programs that run Java, programs that run other, or you can have programs written in other languages, ActionScript also running and creating dynamic web pages. So there's these various languages. HTML pages and CSS and JavaScript and all the other bits and bobs are generally read with web browsing software, Chrome, Explorer, and the replacement one called Edge, Opera. You're familiar with these various browser programs. However, increasingly, it's also used by a lot of other programs as well. So the help in ArcGIS is written in HTML and displayed as a document. It's being used, it's got hyperlinks. It is HTML, but it's not being used within the web. It's being used within the GIS program for the help system. So HTML is used in other things as well as the World Wide Web as well. And just This doesn't particularly matter, but you also may hear of HTTP, which is the hypertext transfer protocol, which is what HTML, the protocol HTML uses for its addressing system, which is built on top of the IP addressing system of the internet. Okay, so the internet uses the IP address to exchange information between machines. HTML uses the HTTP protocol on top of that to transmit the web pages written in the various languages. This is one of the available maps of the internet map. Of course, it's not a map of the internet particularly, it's a map of the World Wide Web, to be pedantic, but as I say, the two terms have effectively become interchangeable in common usage, and indeed by people who write programs that investigate it. It's effectively been converted to the same thing. So in this is another example of a map of the internet. In this case, the size of the circles is representing I think overall I'd have to check what it actually represented, but it represents, I think, the number of connections that go into that web domain, Google, YouTube. So basically the size depends on how many links there are, I think, to Google or whatever, rather than the amount of content and the amount of megabytes that are stored by these companies. You'd have to look that up to see which one of those is correct. I think it's the former. So each one of these represents what's called a DNS. So google.com basically maps onto an IP address or a set of IP addresses, but we can get onto that in due course. All these other circles are all other web domains, and they are positioned according, again, to how many connections they have, but their proximity to each other is determined by the frequency of connections between the pairs of pages. So we can see that Adobe is connected far more through web links to YouTube than it is to Yahoo, for example. Perhaps not surprising if we think about what Adobe does to do with graphics. YouTube also to do with graphics, Yahoo mostly to do with web mail and to a certain extent content. So that's the sort of situation we have with one of the maps of the internet or the World Wide Web. Of course, both the internet and of course the World Wide Web have a spatial component as well. We can think about them in network space, like we just have, without any physical geography. But of course, all those IP addresses, all those computers, all those devices physically exist in somewhere. The users on those systems physically exist somewhere. And this is reasonably, it's explicit in something like Facebook, where each user or each page has a particular geographic location. And in this case, this visualization is looking at the connections between, I think, friends on Facebook, showing the degrees of connectivity between various geographical units. And we can see certainly that there are separate clusters of users in various parts of the world who are more generally separated by sparser connections. So we can make physical maps of this as well. So that's the web and the internet. The Geoweb. So the Geoweb is that part of the internet and the World Wide Web, particularly the World Wide Web, that is to do with the dissemination of geographical data and information in all its forms. So what data is available out there? How is that data made available through maps on the internet, through download facilities, through application programming interfaces that allow us to dynamically query that data on the web? That's what it's basically about. How do we best construct these interfaces? How do we make this stuff available? What kind of information do we need to make available? And as I'm sure you know, it's a very important and growing media for the dissemination of spatial data and maps. I don't think this can be really emphasized enough for your futures. desktop GIS is going to be around for an awful long time to come, and it's going to be still remain core to many business activities. But increasingly, there's a move, as I'm sure you're aware, to away from the need to manage things yourself, manage the software yourself, manage the servers yourself as a company. Why employ IT staff to do it when you can employ Esri to do it through Esri Online or CartoDB to do all that side of things through a cloud-based service. So I think a lot of businesses are moving from, well, we know they are, moving from desktop-based applications to more cloud-based, web-based applications. And I think that trend is just going to increase for the foreseeable future. And it may, in fact, be that we end up with no local software at the end of the day, or very little, or only for specialist circumstances. It wouldn't surprise me if we go that way eventually. And this boom, and it is a real boom, has resulted in even the last, I would say, well, basically the last decade, a huge number of new systems, new companies, new venture capital, new companies being developed. So to a certain extent, the Geoweb, the birth of the Geoweb, it goes back further than the Google Maps API, which came in the late 1980s. But to a certain extent, when Google Maps and Google Earth appeared in the late 80s, that is seen to be the watershed in which internet mapping came out of the universities, out of the research labs, out of the large corporate companies, and became something available to everybody, increasingly available to everyone. So we've got Google Maps API, companies like CartoDB, MongoDB, Tableau, worth looking at. They're not specifically a web mapping company, they're more of a data visualization company, but of course data visualization now involves maps as well. So while there are these specialist mapping companies, mapping is also part of more general activities. So I think there's a mapping extension, a new mapping extension to Excel, for example. So mapping is now outside of just your traditional GIS environments. I think this is about a year old. Just a press release or a little, well, not a press release, a little article in Directions magazine about 8 million CartoDB, which is one of the largest cloud-based suppliers of web products, web mapping services, totally built on open source solutions, including Postgres, managed to raise 8 million to increase its geospatial cloud-based mapping products. So it's big business. Okay, just a few slides showing just a couple of examples. Yeah, it's a bit of eye candy, really. So here we are. This is Esri Online. How many of you have actually logged on, used Esri Online? Yeah, 1, 2, 3. Okay. If you haven't looked at it, we're not going to do Esri Online in the module. Okay, so it's not like we're going to give you, but I would advise you to spend a little time having a look at it and getting an idea for what it does as a commercial package in your own time, just a suggestion. So here's one of the Esri Online applications. Every day, I can't remember which one, is this ND, is this I think it's Landsat satellite. No, it's MODIS, it says right there. MODIS, so the MODIS satellite crosses the Earth every single day, and you can go to Esri Online to the daily planetary imagery, and if something has happened somewhere in the world in the last 24 hours, looks like you've got about a 50% chance of it being captured by the MODIS satellite, you being able to access that satellite image the day after, or almost immediately. So large amounts of satellite data being made available, terabytes, huge amounts of satellite imagery. So everything from that down to more, well, I should say more detailed, specific applications. This is another one on Esri Online using their story map suite of templates. These are templates that allow you to make web maps of various kinds, sort of set out a sort of layout for you. So this one is a timeline with information associated with the Battle of Gettysburg, which I can never remember whether that's in the War of I don't think that's the War of Independence. Is that the Civil War? Gettysburg, a Civil War battle. I can never remember, but yeah, Gettysburg, Confederate. It's yeah, Civil War, American Civil War. So it allows you to put the story map template, provides you with a timeline. You can set your timeline. You can put various maps and features on your timeline to be displayed at different times. So it allows you to build applications like this relatively easily. Here's another example. So this is India's election 2014. It was a live Twitter feed. So you could see where people were commenting about various politicians, Indian politicians during the election. So harvesting data from Twitter and sharing the movements of your cat from GPS trackers. And so that, I mean, that's just a ragtag of internet applications, just with the aim of sort of just illustrating the kind of stuff that's out there. But I'm sure you've seen many, many more examples. So having said that and had a quick look at what's out there, what is the Geoweb actually made of? Okay, we know it's servicing, it's about maps and data, or spatial data and maps on the web. Well, what does it actually, how do we actually do this? Well, there are these, what we can call geographical services on the web. So it consists of these physical applications that have been built that produce maps, that supply data, or that do something for you. So for example, geocoding. You've got a set of addresses and you want coordinates for them. So you might log on to a geocoding service, upload your addresses, they get geocoded. Google does this for you for free, returns you some coordinates for those applications. So that's your geospatial software service. So map services, data services, and software application services on the web. And to make these work, and to work, more importantly, work together and with other bits of software, we not surprisingly need standards and protocols to ensure that the various services on the internet and the data and the maps are interoperable, that people can take those various components, the stuff that comes out of these, rehash them into new products. So what are those standards and protocols? What am I actually talking about? Well, things like the OGC Simple Features standard that we saw for databases, but also things like the Geography Markup Language, GML, which is used to exchange geographic data across the internet. Also things like the EU Inspire metadata standard, which we met at the end of last term as well. So the whole variety of these standards which enable the various bits of software to talk to each other and communicate with each other. So the internet Geoweb at the moment is a collection of isolated applications or semi-isolated applications, bits of data, things like that, spread, managed by lots of different organizations from lots of different sort of IP addresses, different domains on the internet. And I guess this slide asks the questions, is that what it should be? And we'll cover this in the very last, at the end, we'll revisit this at the very end of the last lecture, I think, last talk we have, is considering the concept of a digital Earth as outlined by Al Gore in a speech in 1998. And in that speech, Al Gore described the concept of the digital Earth as a one-stop shop virtual Earth interface onto all the geospatial information there is in the world. So I've heard it described as a sort of, Star Trek type analogy, or you call up this spinning ball of the world, which gives you all the information available so you can visualize and understand what's going on the planet. And there's a real question as to whether this is desirable and practical, or whether, in fact, this sort of multitudinous, diverse, but also slightly more separate situation that we're in is, in fact, a lot more realistic and practical to deal with. So that's a sort of there's a tension there. So perhaps we need more integration, but perhaps more integration and more sort of one-stop or do-all services is perhaps not the best way to go. We'll think about that as we go along. Okay, so that's half an hour. That's just about right for the introduction to the internet, the World Wide Web, and the Geoweb. So, seems a little point to have a break now. So we'll do Clark's classification, see how far we get, maybe have a break, maybe not, see what we feel like. Okay, so Clark. So it's, I can never remember his first name. Clark is a Dutch cartographer. He has written one of the few consistent books on digital maps and digital cartography. You may well have come across Clark in other contexts so far. In I think it was 2001, but it's difficult to tell because the references I find, they reference a book that can't be found and a sort of web book. So it's not really clear exactly where to me, where this classification was originally published. But I don't think that really matters, to be honest. But here, in this case, this diagram on the right comes from the Newman paper, Web Mapping and Web Cartography, which I put on the reading materials. And basically, it is Clark's classification with one additional class. And what it is, so Clark and then later Newman put this list together and basically said, the basic idea is what types of web maps are there out there? Let's just kind of get a handle on the variation in the types of web maps that exist on the World Wide Web. And Clark identified a whole variety of them, from static web maps, dynamically created web maps, distributed web maps, blah, 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 animated web types. The only one that he didn't define on this list was online atlases, which was added by Newman in 2012, or maybe before 2012, but has been added by Newman. Now, this classification, and we'll go through each of these classes one by one, represents both a taxonomy and a trend. So it's both a way of classifying web pages, but also it represents a trend in development and technology through time. So we're adding more classes as time goes on, and our technology allows us to do new things. So it's a trend because of technological advance. The first web maps were basically just images, just a JPEG of a map online, and indeed that's what static web maps are. So the early web technologies, we could do that right from the beginning of the World Wide Web. We could just put a JPEG and embed an image within a web page, and we've got a web map. Okay, it's incredibly basic, but at least we've got something. So this was available right from the very beginnings of the internet, 1989. But things like the ability to personalize web maps, to interact with web maps, to store things in cloud-based servers has only come along in the last decade. So really, or become generally available in the last decade. And that's because the technology simply didn't exist to allow us to do that. This technological advance has allowed a greater richness in presentation than was available in the past. So the technology allows us richness in presentation, and also particularly through the open source software, and encouragement from various government, education authorities. It has increased participation by people in web mapping. Web mapping started off by experts in white coats in universities, in IBM, in large companies, putting it on. It's now, any member of the public can go make, if they're inclined, could go and make a web map within potentially minutes or hours now, if they're so inclined. As we go through this classification, I'd like you to discover that these are not necessarily exclusive classes. So any particular web map may be a member of one or more of these classes. And that doesn't make for a particularly great classification. Okay, well, I think we'll maybe do sort of 3 or 4 of these, and then looks like we'll probably need a short break, and then finish off the last ones in the last half an hour. So, as I've already mentioned, the first one, static web map. And a static web map is simply an image embed of a map in a web page. It's that simple. So you've got some kind of file. Here is a GIF, GIF image file. It's a map. We've also got an HTML document. Okay, you're going to learn, you'll be familiar with this code by next week, but I'm sure we can manage this. It's an image. The address of the image is file.gif. That's the name of the image. We're inserting it into our web page. Okay, what do we get? We go to our web browser, we upload the HTML document and our image onto our web server. Then from the browser, the browser on the client in the client computer accesses the web page with the embedded map, and it's displayed in your browser as an image. Voila, static web maps. Here's an example, the Library of Congress. These are used static web maps. They may sound that basic, that why do we bother? Well, because they're incredibly useful. We've got an awful lot of maps out there that are not in vector or raster format. They're just scanned images. So the Library of Congress, and indeed the British Library, the Scottish National Library, most national libraries now have a map section where they have provided, where you can access scanned versions of, in this case, historic maps. Doesn't need to be historic maps. So you can log on to the Library of Congress. You can do a search. I've just done a search for a map there, and we get various lists of the various maps supplied by the Library of Congress. And if we click on one, here's my favorite place, Central Mexico, we can see that it's in fact, it's a scanned image of a paper map. We can still see the fold lines and everything that were on the map. This is just, I don't know what format this has been downloaded to the computer in, but it's some kind of image format. There's a few basic controls that allow me to zoom in and out on. It says, yeah, okay, so it's JPEG 2000, so it's being served as a JPEG 2000. So it's a JPEG image. You can zoom in and out onto the image. You can change the size of your viewing window, but that's it. You can't point and click on this map in any way whatsoever to get additional information about features displayed on the map. It's just a scanned image. But very useful. You know, there's no need to digitize these images. If I wanted to digitize information off this image, I'd probably be the first one to ever actually want to do that. I could download the image, and then I could georeference it, and then I could digitize some stuff myself into vector format. So that's your static maps. Obviously, they're used a lot as well for backdrops, as background mapping. So, for example, you bring up Google Maps, just for navigation or whatever, to find out where somebody's address is. That is being served to you as effectively a static map. you're getting that is an image, just an image embedded. You may be able to pan across it and it will load up a bit more image onto it, but that's what's being delivered to you as a static image. Okay, class 2, dynamically created web maps. Okay, so basically dynamically created maps are maps that are built on the fly. And on the fly, what I mean is on demand. Somebody wants a map. The map isn't there as a JPEG that's then displayed. It's created from the data and then given to the user. Basically, mostly the data comes from an underlying database. That's normal, but it doesn't, depends what you call a database. It could be just reading local files and things like that, but usually I would say it would come from a database application. You need to refresh the map in the browser to see any changes in the data. So for example, if you're something like that Twitter map of the election, tweets are going up constantly, you might need to refresh it, want to refresh it every few seconds even, to see the changes on the map. Just this use of dynamic. Dynamic is used in many different contexts in GIS. One of them is in geovisualization, in which case, and under geovisualization, dynamic means sort of movement and animation on a map. It doesn't refer to how that map is created from the data. So you may see dynamic used in different contexts. Be sure you understand the Geoweb context of made on the fly. There's one. Hey, the very Google map I was talking about, okay? That is, so what's going on here? Well, we're being fed effectively a static map, as in it's a image. An image is being sent to the browser. This is this type of image that allows you to zoom in, zoom out, pan any way you like, unlike the Library of Congress, which is just within the bounds of the scanned map, is sometimes called a slippy map. So if you hear the word slippy map, that means something that you can drag and zoom and move and slip about on, you know. Slip about, move it about, slippy map. Now in this case, we're displaying the traffic layer. Now the traffic, do you know where Google traffic comes from? Comes from your Android phone. So if you own an Android phone, basically Google is monitoring where you are the entire time. Unless you'll probably turn off all location-based services or something like that. So it's monitoring all these Android mobile phones in this area, and it's working out how fast each one is moving. And they sort of guess that if you're going at a relatively slow rate, 3 miles per hour, you're walking. However, if you're in a car and or in the road, then chances are you're in a vehicle. Now, of course, if you heard the news a couple of weeks ago, the speed of traffic in London is now slower than walking pace on average. So obviously their algorithms have obviously got to be reasonably clever. But what they do is basically find the Android phones that are on various roads, then they work out the average speed, and that's where the coloring of the lines comes from. So this is all being dynamically done in effectively real time, or as close to real time as they want. So the maps, the lines, the code lines are being gathered from, dynamically gathered from the servers, phone servers that are dealing with where all these Android mobile phones are. All right, one more and then we'll have a little break. Oh, sorry, that was dynamic. Yes, it's being created on the fly. So if we refresh that a few minutes later, maybe this traffic jam has cleared. Yeah. Distributed web maps, number 3. So these bring data together from 2 or more databases. So it's distributed over multiple sources. These are often on different servers, but they don't need to be. A server is just a computer that's pumping out data, basically. So distributed maps are often, but not exclusively, thought of as sometimes as mashup. So mashup You may have heard mashups in music, mashups in, I don't know, art, and things where we can mash up data, which is basically people publish data because they collect it, and for whatever reason they publish it. We'll talk about the various reasons people publish data on the internet in due course. So people pick up these data feeds and put them together to create a new product that's novel, that puts together different data sets, diverse data sets, in new ways to create new products. And those is often called mashing up data. We'll see an example. And because these mashups require the gathering and bringing together of data from lots of different locations, potentially lots of different locations, you need interoperability, otherwise it's going to be an absolute nightmare. So so mashups and distributed websites thrive on interoperability. If you don't have interoperability, it's going to be really hard. Not impossible to do these things, but hard. If things are interoperable, these things become easy, or relatively easy. So here's an example of a distributed web map. So this is the Global Hazards Atlas produced by the Pacific Disaster Center, wherever that is. So we've got maps, we've got cyclones, earthquakes. It's a one-stop shop for all your disaster needs, basically, or your forthcoming disaster. Well, it's not disaster needs, it's more your forthcoming and ongoing disasters here. Okay, and we can point and click, and we can get information about the various hazards. So here I point and clicked on an earthquake in Papua New Guinea, and then I can go to more information, and that brings up information on that particular earthquake in Papua New Guinea. And if we look down the detail of the hazards, we can see it says has a status of new, whatever that means, but presumably it's relatively new on the map. And importantly, well, what's the source? The source is the USGS, the United States Geological Survey. So this is where the data is coming from for the earthquakes. If, however, we look at a cyclone, we can see that the source is the JTWC, which is the US Navy Joint Typhoon Warning Center. So we've got earthquakes coming from the USGS, we've got cyclones coming from the US Navy. So it's been put together, mashed up into one single map. We're just going to play on a little bit. Animated maps, very straightforward. Display temporal changes in features. But we can also use animation to do different things. So we can say we wanted to show the same variable, different variables at the same location. Well, we could show a map of one set of variables, and then we could fade into the map of the other set of variables, for example. Okay, so we can do different things than just time. We can also take things, combine space, time, attributes to tell some kind of story using animated maps or sort of stories. The other type that I've added in that I've not seen mentioned in any of the literature is things like video map flyovers, particularly of things like 3D landscapes and things like that. That's another type of animated map to me. These latter two are not, these are my additions rather than the literature talks about these two, but I think these two should also be included in this as well. Well, what amazing, whoops, that in theory, maybe it will wake up. There it goes. How democracy conquered the world. This is just an animated GIF file. So GIF file is a form of image format. There's GIF, but GIF supports multiple layers of images, which then cycle through to allow you to produce very simple animated maps. So this is basically a stack of GIF images that just cycles through, showing which countries had a democratic government at various times. Okay, should we take 10 minutes? Yeah, okay, let's take 10 minutes, and then hopefully it'll just be 20, 25 minutes to finish off.